Good day, grade 8s. I'm Miss Babo, and today's lesson we are going to be learning about visible light. In this section, we are going to look at how we are able to see light and how light is absorbed and reflected on different types of objects, as well as how light is refracted and dispersed when it travels. Firstly, let's start off with the radiation of light. Where does light come from? Natural light will come from luminous objects, and we say these objects are able to emit light. Objects like the sun and light bulbs can give off light. Now we know the sun is our main source of light on Earth, but a light bulb is also classed as a luminous object as it is able to emit or give off light. When we refer to the radiation of light, we refer to light as being part of the electromagnetic spectrum, and it travels in waves. Each wave in the electromagnetic spectrum has its own unique wavelength and frequency. Now, a wavelength is the distance of one wave, and the frequency is the amount of wavelengths that are passing through a specific point. When we speak about a longer wavelength, it means that the wave has a lower frequency. Light travels in straight lines, and it travels at about a speed of 300,000 kilometers per second through a space, and it takes light about 8 minutes to reach Earth from the sun. Now let's look at the difference between what a wavelength is and what a frequency is. So with wavelength is measured from one wave to another. So if we start here, this is the top of one wave and this is the top of another. So this determines the wavelength of the light traveling here. If we have a look at blue light, it is a shorter wavelength because the distance between these two waves is a lot shorter. So like we've mentioned previously, the longer the wavelength, the lower the frequency. The shorter the wavelength, the higher the frequency. With regards to the spectrum of visible light, white light we see is actually made up of 7 different colors of the spectrum. When these 7 colors are traveling together, it forms white light. Now, when white light changes direction, or when there is a change of direction, the colors are spread, and that is called dispersion. As you can see in this diagram, the light enters our glass prism over there, and due to the change in direction, the 7 colors are split, and this is what we call dispersion. With regards to the spectrum of visible light, orange and red have a longer wavelength, which means they will have a lower frequency. On the opposite side, if we have a look at the violet, the indigo, and the blue, they have a shorter wavelength, which means they have a higher frequency. When we speak about different objects in this section, we are going to be looking at opaque and transparent objects. So let's start with a transparent object. Transparent object will allow light to pass through it, meaning there is no shadow. An example here could be a window. An opaque object does not allow light to pass through, meaning the light that hits the object will either be absorbed or reflected. An example there could be a mirror, which reflects light, or a simple thing in this scenario as a car. Light cannot pass through the metal of the car. Now we have a translucent object. A translucent object means that it is semi-transparent, meaning not all the light will be able to pass through, only some of it. An example like that could be a plastic bag. Some light will be able to pass through, but not all of the light. So when it comes to the absorption of light, an object will appear to have a color because some colors are absorbed and some are reflected. If we have a look at this diagram over here, we have a red object. When white light travels to the red object, the other colors that travel with it are absorbed and only red will be reflected. If we have a look at our green diagram over here as well, our green diagram will absorb the other colors and only green will be reflected, which enables us to see the green color. But when it comes to black objects, like this one over here, all the color is absorbed that is traveling in white light, which will then enable us to see a black object. But with white objects, like with this object over here and this one over here, all light is reflected. Remember, white light is made up of the 7 colors. So when they all reflected at the same time, the object appears to be white. Now, with regards to reflection of light, when light is shined on a smooth object like the surface of a mirror, it can bounce off in a new direction. When light shines on rough surfaces, the light forms many reflection angles which will scatter. The light shining directly on an object is called the incident ray, which is this one over here. This forms the angle of incidence with the normal line. So this is the angle of incidence that the incident ray will form with the normal line. When the light is reflected, it forms an angle of reflection with the perpendicular invisible normal line to give us the reflected ray. On a rough surface, as you can see here, the incident ray, which is these rays over here, will hit the surface, and due to it being a rough surface, there will be different rays of reflection which will come off, meaning different angles of reflection that occur. At this level in grade 8 physical sciences, you do not have to know how to calculate the angle. You must just know that there are angles of incidence that occur between the incident ray and the perpendicular normal line on the surface, and there is an angle of reflection that occurs between the normal perpendicular line and the reflected ray. So how do we see light? Light is absorbed by objects that does not enter the eye. Only the reflected light or the direct light from luminous objects can enter the eye and be interpreted by the brain. So what happens here is that light travels through the eye and hits the retina at the back of the eyeball. The retina is a thin layer of tissue that lines the back of the eyeball, and it consists of cells that are sensitive to light. Light will then enter the eye and it forms an image on the back of the eyeball. There are receptor cells which will convert light energy into electrical nerve impulses. Those impulses will travel through the optic nerve and to the brain, where it is interpreted as what image we have seen. So all of this takes place in the eyeball. The optic nerve is triggered, which will allow our brain to interpret what image we are seeing. Now we look at the refraction of light. So how we can explain the refraction of light? It is the change in direction of light when moving from a colorless object to another. An example that we can see here is by placing a pencil in a glass of water in our middle cup. Same concept as if you were to place a straw in cold drink. It tends to look like the straw is broken. It is in fact not broken. It is called the refraction of light. So this change in direction will allow the light to be refracted, which changes the image that we see when we look through it. The steps of how refraction occurs. Firstly, the light goes through the colorless object or the medium at an angle. What we mean by medium is the object in which it flows through. It then causes the light to change direction and to refract towards the normal or perpendicular line. So the normal or perpendicular line is our invisible line that's perpendicular to the surface of the object. When the light moves out of the medium, it will refract away from the normal line, and when the light refracts and changes direction, it distorts what we see. An example of where we can see refraction and reflection in our natural world will be the formation of rainbows. So how rainbows are formed is sunlight will travel through a water droplet or water precipitation in the air, where it is refracted as it enters into the raindrop. Then towards the back of the raindrop, it will be reflected and refracted as it exits the raindrop. That is how we are able to see rainbows. This refraction here shows us that there was a change in direction, which will then cause a rainbow. So if we were to look at how refraction occurs, we have the diagram below. We have one colorless medium, which is air, that light passes through into another colorless medium, which is glass, and exits on the other side. If we look at the numbers involved here, we have the incident ray, which is the ray that will enter into the colorless medium. Perpendicular to the surface of the object will be our invisible normal line. The normal line will form an angle of incidence with the incident ray. It will then form, with the change of direction, another normal line where it will form the angle of refraction, which will show us where the emergent ray is. The last section for light is lenses. A lens is able to either refract light or to focus light. We have two different types of lenses that a person could use if they were perhaps if they have a sight issue. We have convex lenses, which are used for far-sighted vision. Now, far-sighted vision means you see things that are far away better than when they were close up, and near-sighted vision means you can see objects near to you very clearly, but objects that are far away will become blurry. So how we correct issues like this? By placing a convex lens for far-sighted vision and a concave lens for near-sighted vision. Thank you for attending the lesson. We will see you soon for the next section of Natural Sciences.